Horses and humans have a long history together, ever since horses were first domesticated about 4,500 years ago in the steppes of Central Asia. Horses transformed human culture from their importance in pulling heavy loads to their value as a source of transportation and for cavalry of various sorts that have long been essential to warfare. Only with the invention of the automobile a little over a century ago did horses become less essential for human culture. Horses were long thought to have lived only in Eurasia, and not until Columbus brought them to the New World in 1493 did they spread to the Western Hemisphere and become a part of culture here. But in 1833, Charles Darwin was on the voyage of the Beagle and found an undoubted horse tooth in Argentina, mixed with other animals that had vanished during the end of the last ice age. In 1841, Sir Richard Owen described small fossils from the London clay that he called Hyracotherium or Hyrax beast, dating back to about 55 million years ago. They were once thought to be horses, but now they're known to be Paleotheres, a group that has branched off early from the common ancestor with horses. Other fossil horses were also found in Europe. So in 1873, Russian paleontologist Vladimir Kovalevsky, at the same time British zoologist Thomas Henry Huxley, both postulated horses had evolved in Europe from Hyracotherium to Ankytherium to Parian to Equus. In 1876, Huxley sailed to the United States to give a lecture tour and talk about the evolution of European horses. He visited the famous Yale paleontologist Othniel Charles Marsh at the Peabody Museum, who showed him his amazing collection of fossil horses from many time intervals of the Cenozoic in the Rocky Mountains. As Huxley said, quote, at each inquiry, whether he had a specimen to illustrate such and such a point or exemplify a transition from earlier to less specialized forms to later and more specialized ones, Professor Marsh simply turned to his assistant and bid him fetch box number so-and-so, till Huxley turned on him and said, I believe you're a magician. Whatever I want, you just conjure it up. Huxley then threw out his planned lecture on how horses had evolved in Europe and instead displayed diagrams provided by Marsh that document how horses evolved in North America, and only occasionally did they spread to Europe as well. Huxley's little sketch of Eohomo riding Eohippus is a whimsical side of this important discovery, the first well-documented example showing evolution to a modern species. This simplistic, straight-line evolutionary view is still correct in its broadest outlines. Horses do get larger, their limbs and especially their toes get longer, their teeth develop higher and higher crowns. But this is the way it was understood in 1925, a full century ago. In the ensuing 100 years, thousands of additional horse fossils have been found, showing the simple linear patterns is not a good representation. Instead, horse evolution is bushy and branching, with many species overlapping in time. In one quarry, about 12 million years old in northern Nebraska, there are 12 different species of horses who lived side by side. Let's go back to the beginning. The earliest true horses were found in beds around 52 million years old in the Rocky Mountains, and their skulls and teeth look almost identical to the earliest tapirs and the earliest rhinos, showing how close they were when they first began to diverge. These early horses are the size of a beagle. Once called Hyracotherium or Eohippus, they now belong to a variety of genera, including Protorahippus, Sifrippus, Minippus, Arenahippus, and Xenocohippus. By about 50 million years ago, a slightly larger, more advanced form, Orohippus, is found in the Rocky Mountains, along with Epihippus around 47 million years ago. In the Big Badlands of South Dakota, we find Mesohippus, in beds ranging from about 37 to 32 million years ago. It is about the size of a goat, and its fourth finger was lost from its hand, so it walked on only 3 fingers and 3 toes. By about 36 million years ago, a slightly larger Myohippus had evolved, with 3 species of Mesohippus found in the same beds as Myohippus. Central toes of Myohippus are now large enough that they contact one side of the ankle bones, a key indicator of the greater and greater loss of side toes and the expansion of middle toes. About 24 million years ago, Parahippus appeared, one of the earliest members of the equine branch of the horse family tree. It was the size of a German shepherd, with even longer limbs and reduced side toes. It also had higher crowned teeth, suggesting a gradual adoption of a diet of gritty vegetation. Meanwhile, another side branch of horses are known as the Ankytherines. They continued to retain their very low crowned cheek teeth, focusing on a diet of soft leaves, while the main branch of equines are evolving higher and higher crowned teeth. Modern horses have extremely high crown teeth with very deep roots, so they continually survive the grinding of their tough, gritty grass diet, and always have additional tooth surface pushing up from below. By contrast, all ankytheres have low crown teeth like the earliest horses, even though some of them, like Megahippus mckennai, were as large as a living horse. By 12 million years ago, we see a huge radiation of different three-toed horse lineages, including Merychippus, Pliohippus, and a wide range of Hipparions. These evolved mainly in North America, although some Hipparions escaped to Eurasia. The condition of the deeply pocketed fossa on the face of the Hipparions is one of the key features that helps distinguish the different groups. About 3.5 million years ago, horses escaped North America and crossed the newly formed Panama Land Bridge, where they evolved into a unique group of horses known as Hippidions. These horses had deep notches below their nasal bones, suggesting they had a short proboscis or even a trunk, which might have helped them feed. About the same time, the first truly one-toed horses appeared, beginning with Dinohippus and culminating with Plesippus and then the modern genus Equus. Today, all living horses, zebras, asses, and donkeys walk on a single middle finger bone and a single middle toe bone. But every once in a while, a horse is born with fully formed side toes, sometimes even bearing a hoof. These horned horses were thought to bring good luck, and Julius Caesar famously rode one into battle. It turns out that early in horse embryonic development, there are still buds for 3 or 4 toes, but the development of these toes is normally suppressed until the gene switch that turns off side toes fails, in which case a horse is born with its ancestral 3 toes again. Nevertheless, every horse alive still has the genes for side toes like those of its ancestors, another striking feature of their evolution. During the Ice Ages, horses of the living genus Equus were widespread over North America, Eurasia, and Africa. There's still a lot of controversy over how many species of Ice Age horses can be recognized, although many are not known from complete skeletons. But even their DNA, which can be compared to living horses and zebras, helps us sort them out. Of the horse species alive today, Przewalski's horse is generally the closest to living horses. Found in cave paintings of our ancestors and once widespread over the Eurasian steppes, it was thought to be extinct in the wild and only preserved in zoos, although it has since been introduced to its native habitat in Mongolia. There are only 10 valid species in the genus Equus, including 4 species of zebra, the plain zebra, mountain zebra, greve zebra, and the recently extinct quagga of southern Africa, 4 species of wild asses, kyangs, and onagers, from which donkeys were domesticated. This is a small fraction of the diversity that horses once exhibited. As the extinct quagga and the nearly extinct Przewalski's horse demonstrate, many species are vanishing from the wild, leaving only a few species of zebras and asses plus our domestic horse as the only common equids left on the planet.